Hello everyone, welcome back. So in this video we are going to understand the problem number 761. It's a special binding string. So very first we have given a special binding string, and a special binding string is a binding string that has equal number of you can say zeros and ones, right? And at any prefix the number of 1s, right, should be greater than equal to number of 0s. Okay, so that's condition exactly is like valid parenthesis. So one behaves like, let's suppose is, let me tell you how. So what are the things we have given is, it is saying that the binding string is a binding string that has two properties basically. The very first we have is number of zeros is equal to the number of ones, and point number two is every prefix of the binding string, right, that has at least many 1s and 0s, right, means has equal number of 1s and this. But some conditions we have given. What are the conditions? Saying that at any prefix, right, at any prefix number of 1s should be greater than equal to number of zeros, right? If that the condition matching, right, and these condition matching, right, number of this, if these two conditions are matching, it means it is a special binding string. And if the second condition is that it is saying that, let's suppose is, if we can say that one behaves like as a starting braces, right, we can say like this, and 0 behaves like the closing braces, right, starting braces and closing braces. So this problem is basically a given valid parenthesis, right? If you remember, there is a problem, valid parenthesis problem, parenthesis string, right? This is a valid parenthesis string. There is a problem in the Leetcode. If you have already solved, then you can understand easily. So basically, so in a given valid parenthesis string, we have to rearrange its special substring to make the lexicographically string, largest string, we can say that. Okay, so if we have a given valid parenthesis, right, rearrange its special substring to make the lexicographically largest string. Let's suppose, let's go with the example. Okay, let's say that we have given this example where we have given 1 1 0 1 1, and then we have 0 0 we have given, right? We want the largest lexicographically, right, special string. This is what we need, right? So very first, what we should understand the structure. Think in parenthesis, right? So let's suppose if we will replace that, I told you that if we can replace 1 with the opening parenthesis and 0 with the ending parenthesis, right? If we will replace like this, it means this given string will become like this. How it will become like that? It will look like this. So when we convert this, the opening parenthesis will become starting parenthesis, then we have the closing parenthesis, we have, right, this one. So it will become a closing parenthesis, then it comes for the starting parenthesis, then it's come for the closing parenthesis, and then parenthesis. Now we should check that is it true or it's false, right? Let's suppose if we'll say this is the starting parenthesis, so for this one we have the closing parenthesis, for this starting parenthesis we have the ending parenthesis, for this starting parenthesis this is the ending parenthesis, then we have this starting parenthesis, this ending parenthesis. Means this is a string, and that's a valid parenthesis string, we can say, right? Because if all the opening parenthesis is closed by the ending parenthesis, it means it's a valid parenthesis, right? So basically, in the very first thing I will say that understand the structure where you have to think like a parenthesis. So you have to replace all the ones in opening parenthesis and all zeros with the ending parenthesis, like that we have seen here, right? So basically we want to check a valid parenthesis string. If this is the thing we have, means we should understand that every special binary string can be broken into smaller primitive special parentheses, right? So let's understand. So basically what I'm trying to say, we know that we have some special binary strings we have given, right? But from this binary string we have to check that every special binary string can be broken into a smaller primitive special substring, right? How? Let's suppose just like we have that starting parenthesis, then we have that ending parenthesis, then 3 times we have seen like this, right? It means if we will convert this into, let's suppose that if we'll convert like this, we have starting, then we are closing, then we have starting, then we have closing, like that we will think. So it will be easy if we will broke this into smaller pieces, right? Means we have basically we have broken into these pieces, right? So we can easily understand. So we want to split into a valid balanced chunks like that we have seen now, and recursively we will optimize inside and we'll sort those chunks in descending order and we'll join them in the back, right? So if we will do like that, it basically it will check all the smaller primitive special string, and if we'll see that the that because very first we have splitted the in the valid chunks, and we will recursive way we will check every inside. Let's suppose we'll go and we'll check all the recursively, and then we'll sort the chunks in the descending order, so it will work. Okay, so let's try to understand how we will solve this problem. Let me go to here, and then yes, so basically the problem we have is make largest special, right? It means this is the method we have given where we have given the strings we have given. And what is this intuition that we have implement this solution? Like we have treated that all the ones is a opening braces, right? And all zeros are closing braces, or you can say 1 is a open bracket and 0 is a closed bracket, right? That we have seen. Then we will split into a smaller valid blocks, and we need to store somewhere, right? So that is the different thing, but basically we want to split into a smaller valid blocks, and recursively we will maximize inside the blocks and we'll sort the blocks in descending order. It means basically because the graphically we have the leading 1s should be equal to the largest string, right? So we have to put the largest block first, and inside we will overall will move, right? So what we will do, we'll check first if the length is less than equal to 2. It means we will return that string itself, because if the length is itself is less than equal to 2, no need to check further, we'll just return the because there is only two braces is there, right? Starting and ending braces, unless maybe only one is there. Then we'll create the list, right? And we'll create a list here, and we have a count and start. So what we are trying to do here is very first we'll go for all the string, right? We'll check if it is equal to 1, means we have count, otherwise it will go minus, right? Means for the opening braces, ending braces, if the opening braces comes, right, we know that this is 1, it means count will increases, otherwise count minus 1 will happen. If the count is equal to 0, it means that recursively we have to solve the middle part, right? How? We have to take the substring, right? Let's suppose we'll start from 1. We will do means that we know that start is starting from 0. So now we have taken the substring start plus 1, means we will remove one starting braces from the index number 0, and we'll go from the index number 1, and so on. We have to go till the last, right? Like that we have to check, and we'll check this is a inner string, right? And then we'll go to find the list where we will add 1 and the inner. So we'll keep adding this value, because this is the inner part, we are adding the opening braces, and this is our ending braces, right? Then we'll say start is equal to start from I plus 1. So we updating our start each time like this. Okay, so this for loop will keep continuing, and we'll check with all the, and we will check recursively all the inside blocks also. Okay, so once this is done, then we have something on the list, right? So we will sort it into the we want to sort the blocks, those blocks, we want to sort that blocks into descending, right? So we have to take the collection dot reverse order and we'll sort that. Now we have to build a string result, and from the result, let's suppose from the list, right? Because we have already done that, we will append onto the result. Once we have done this one, then we just need to return the result, right? Well, it will do the result dot toString and will convert into the toString, so it will work. Okay, so this is what we have to do. Let me tell you in detail once more. Okay, so this is a base case, guys. You know the base case where we have checked that why we need this base case, basically because we have the smallest valid string, which is a special string. Let's suppose if we write 10, right, it means this is a opening braces and the ending braces, means this should be valid and you can't rearrange it, right? So if the string length is, let's suppose 0 or 2, right, we have to return as it is. We don't need to do anything, we will just return it and we'll stop doing the recursion further. Okay, we will not do further. Then we will create the list, right? So this is a list part, right, where we have to define this list, and these counts we have also here. Basically this part we have to write, because we know that if we will take this list, right, it means we have to store all the balance, a special substring that found at this level, so we will add there. And then we will take the count, so this count will balance the counter like a parenthesis depth, and we have the start. This is a where the current block will begins, and we will start from there, right? Then we will have a for loop we have, and this for loop, what it will do is we will scan the string from index 0 to the last, right? So basically the given string will be there, some, let's suppose 110011 and then 000, like that we have. So we'll start from here and then we'll keep moving ahead, right? Let's suppose once this start is done, then we'll start from here and then we'll keep moving ahead. Like that we have to keep moving ahead, and we have to check the balance string, right? We want to move from the, you can say, from left to right, and for that we have to use, right? So basically we will start from I equal to 0 and we'll keep moving ahead, right? So we want to move like this. Next, if we will talk about that, we have is the s.char at I equal to 1, and the count is plus plus, or else count minus minus. So exactly like a parenthesis, we know that if 1 is the open braces we have, right, like this, and 0 is like for the closing braces, right? So it means one comes, means the increased depth is increasing, right? Means we have to increase the depth, we can say, right? And then if once comes, means we have to decrease the depth. This is what we need to do. Then we'll check if count is equal to 0, it means we will detect the balance substring, means the string that we have found. Let's suppose start from 1100, then let's suppose it is a 1, this is a 0, this is a 1, this is 0, means from here to here, if we will find that this is what we have given, let's suppose, then it means the count will come 0, right? Because very first it came, it become 1, then 1, then 2, then 1, then 0, means the count is 0. And that time we will say, okay, we have detected a balance substring. This means we found a complete special substring. Let's suppose if there is some more values there, let's suppose like this we have, or something, some elements are there here, right? Means this part of the substring is nothing but what you call the complete special substring, that is from here to here, right? So if we will found that, means when the start is at where, at some index, let's suppose. So what we will do, we'll start from the I, and we'll say, okay, this is the thing that we have. So because the balance string return to 0, so we'll return it this value. Okay, like that we have to set the value. for the if this is comes 0. Okay, now comes, let's suppose that I we have is at 0 and some characters will be here. Let's suppose some character, let's suppose string was given is 110111 and we have 000 we have. Let's suppose like this we have. So very first, that if we want to track, let's suppose I is here, so index will be 0, then we have character, let's suppose the character is nothing but is coming is 1 right here, so character is 1. Okay, then we'll say okay, what is the count? Will count is also 1. Like that, when 1 is here, the we'll move to here, right? So character is 1, it means count is 2. Like that we have to move, and we'll keep moving ahead like this. And whenever you will find, let's suppose 0, it means you found here 0 when when index is 2, so here count will become 1, right? Like that we'll keep moving ahead. Once time will come where count will become 0, and there will be some step will be there. Let's suppose some step is like this we have, so you will get the 0, count is 0. So once the count is 0 at some index, right, so the substring we have to find here. What is the substring? Because from here to here itself, if we'll talk about, is giving the count is 0, because if we'll start from here to here means the substring from 0 to 7, right, it gives you the same exactly same value. So we'll say okay, 11011 000, this is the string is there. So now we will proceed inside, right? We have to proceed inside and we have to find in the recursive way. We have to find how we'll find the recursive way. I'll show you. So very first, once you find that substring, you will go inside and you will find the recursive part. In the recursive part, we have the inner we have, right? So what we will do, we will go with the substring that start will be +1. Okay, so basically we remove two things, outer 1 and 0, correct? If you remember, we have taken substring, it was 11011 and 000 was there, right? It means I want to remove two things. The very first, this part and this part. I want this part. Understand? So for that we have to start from I +1, the start +1, and we'll go to that I. Means we want to remove outer 1 and outer 0. And so if the string is this one, right, we will make the string is 101100. Understand? So this is called inner string. So we will call the recursion on this string now. So this is a substring. Now we come and we will call recursion on this string. So why we have removed outer layer? Because the structure is we have 1 plus, let's call the inner special string. Okay, and then we'll do +0. We only rearrange the inside one. Okay, and then if we want to rewrap, means we have to wrap it back. So once we'll wrap it back, we'll add it here. So we'll say okay, list, you just add here. What we'll add? First add 1, then you add the inner string plus this 0. So if you see here, technically we have added like this. Okay, so we have to wrap it back. Okay, because we will perform the recursion on this inner string, right? But we should not lost this part. Understand? After recursion returns the optimized inner string, let's suppose this one. So we'll rebuild the full block, right? Once you will rebuild the full block, we'll move the start from start plus I +1. Okay, so we will move the start pointer. So the now next block begins after this, right? And this is a critical. So without this you won't split correctly. Okay, So after the loop, once this loop is completed, we have blocks. For example, let me show you. So or don't remove. Let's suppose, give me 1 second guys. Okay, so let's suppose that we have something. So very first it was this was the string was given, right? 1 1 0 1 1 0 0, right? Like that we have, and we have got this, right? But we do something like this. Let's suppose something like that we have. Okay, what I'm trying to say, think that, let's suppose that initially we got 1 1 0 1 1 0 0 was there, right? And we got from here is 1 1 1, because these three will become 1, right? Because we have to reverse it, right? Once this got reversed, because we are operating on this one, right? Let's suppose after once we complete this part, we have to sort that is descending part, right? It means all these 0 will become 1, right? Then it comes 1 1, so it becomes 0 0. Then we have 0, this will become 1, and then we have 2 0. 2 1 is become 0. Means from here, from this given string, we will make this string, correct? But for something like this, let's suppose if we have 1 1, then we have 0 0, then we have 1 0 1 0. Okay, if we want to convert this, you may get, let's suppose the very first, if we, because we have to split, so you may get, let's suppose is 1 1 0 0, then we have 1 0, then we have 1 0. Because if we will split this string, it can be look like this, right? 3 part of this splitted string will be there, right? Means basically I want to say, from here you got this string, but for this string you don't know, right? But it could be that you will get this string, right? Because this was balance substring, this is a special substring was there, right? And you got the completely. But in this case you will not get, and you will get, because the inner substring can be different. If the inner substring can be different, or because this is not balanced, if this is not balanced, you will get the splitter thing, right? So you may get like this. So this sorting, that when we do a collection.sort, so this sorting step is a magic. We sort the block in descending lexicographically. Why? Because lexicography larger means more leadings 1s is there, right? And let's suppose we have more leading one, it means lexicographically 11 0 0 should be bigger than this 1 0, right? If 1 1 0 0 lexicographic is bigger than 1 0, because if you have more 1s means lexicographically you are more value is there, right? Means we want, let's suppose 1100, yeah, 110, not 1100, we can say 110, and then 10 will do the plus, correct? Because lexicography it is a bigger one. But we cannot do, let's suppose is 10 plus 1100. You cannot do this, but this is not valid, guys. This is valid because more 1s is valid one like this. Okay, so this is valid. So this sorting will ensure largest block comes first, right? Which one is the largest block will come first, and this will work. Okay, I hope you're understanding, right? So we have to now rebuild the string. So you will take a, what you call the string builder, right? And we have to join all the sorted blocks like this we have, and once you will sort it, you will return the result. Okay, I hope you are understanding the problem, guys. Now it will come back to here. So if you see here, you got the string here, right? If you have 10, you will return the 10. Like that we have to think, and it will work. I'll request you to write the time and space complexity for this problem, and if you understood the problem, you can write the comment understood, and please like and subscribe this video, share with your friends, and please keep supporting ExpertFunda. In case if you have any doubt or anything, please ping me in the comment box. And if you are looking for learning Java, DSA, you can join my online classes, and for that you need to ping me on the WhatsApp. So we'll connect from there. Let's do the inquiry and let's have the schedule. Thank you guys. Thank you for watching this video. I'll see you in the next one. Thank you.